A red leg panel is a specific type of electrical panel primarily found in industrial and commercial environments. The term red leg refers to the red painted exterior of the panel enclosure. These panels are designed to supply electrical power to heavy-duty equipment and machinery commonly used in industrial applications. Unlike standard electrical panels found in residential settings, red leg panels are typically larger in size and possess a higher capacity to handle significant electrical loads. This increased capacity is crucial for powering large motors, industrial machinery, and other high-power consuming devices. Red leg panels incorporate heavy-duty circuit breakers, which are protective devices designed to interrupt the flow of electrical current in the event of an overload or short circuit. These robust circuit breakers provide enhanced protection for the connected equipment and the electrical system as a whole. Additionally, these panels often include other protective devices, such as surge suppressors, which safeguard against voltage spikes, and ground fault circuit interrupters, which protect against electrical shocks. The primary function of a red leg panel is to distribute electrical power safely and efficiently to various loads within an industrial or commercial facility. They are often used in manufacturing plants, factories, warehouses, and other settings where heavy equipment and machinery are prevalent. The red color of the panel serves as a visual identifier, indicating its purpose and voltage level. This helps to prevent accidental contact with the wrong voltage or equipment. Red leg panels are typically wired with three-phase power, which is a type of alternating current electrical power distribution that is more efficient than single-phase power commonly used in residential settings. Three-phase power allows for the delivery of more power with smaller wires, making it ideal for industrial applications. The specific voltage of a red leg panel can vary depending on the application. Common voltages include 208 volts, 240 volts, 480 volts, and 600 volts. The selection of the appropriate voltage depends on the voltage requirements of the connected equipment. When working with red leg panels, it is essential to follow all applicable electrical codes and safety regulations. Only qualified electricians should install, maintain, or repair these panels. Proper personal protective equipment, such as gloves and safety glasses, should always be worn. Before working on any electrical equipment, it is crucial to energize the circuit and verify that it is safe to work on. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. Regular maintenance of red leg panels is essential to ensure their continued safe and reliable operation. This includes inspecting the panel for any signs of damage or corrosion, tightening connections, and testing circuit breakers. Any damaged or worn component should be replaced promptly. The National Electrical Code, or NEC, provides comprehensive guidelines for the installation and maintenance of electrical equipment, including red leg panels. It is essential to consult the NEC and other applicable standards to ensure compliance. The NEC specifies requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. For example, NEC Table 310.16 provides ampacity ratings for various conductors based on their size and insulation type. This table is used to ensure that conductors are not overloaded, which can lead to overheating and fires. The NEC also requires that all electrical equipment be properly grounded to provide a path for fault current to flow back to the source. This helps to protect against electrical shock hazards. Grounding is typically achieved by connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe. The NEC also specifies requirements for overcurrent protection, which is provided by circuit breakers or fuses. Overcurrent protection devices are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC requires that overcurrent protection devices be sized appropriately for the connected load. In addition to the NEC, other standards may apply to red leg panels, depending on the specific application. For example, the National Fire Protection Association, or NFPA, publishes standards for fire safety, including NFPA 70E, which provides guidance on electrical safety in the workplace. NFPA 70E covers topics such as arc flash hazards, personal protective equipment, and safe work practices. When selecting a REDLEG panel, it is essential to consider the specific requirements of the application. This includes the voltage, amperage, and number of circuits required. It is also important to select a panel that is appropriately rated for the environment in which it will be installed. For example, if the panel will be installed in a wet or corrosive environment, it should be rated for that environment. REDLEG panels are available in a variety of sizes and configurations. The size of the panel is determined by the number of circuits it contains. The configuration of the panel refers to the arrangement of the circuit breakers and other components. Some panels are designed for surface mounting, while others are designed for flush mounting. Choice of mounting method depends on the specific application. When installing a REDLEG panel, it is essential to follow the manufacturer's instructions. The instructions will provide detailed information on how to properly install and wire the panel. It is also important to ensure that the panel is properly grounded and that all connections are tight. After the panel is installed, it should be inspected to ensure that it is working properly. This includes testing the circuit breakers and verifying that all connections are tight. Regular inspections should be performed to ensure that the panel continues to operate safely and reliably. If any problems are found, they should be corrected promptly. Working with electricity can be dangerous, so it is essential to take precautions to protect yourself from electrical shock. Always wear appropriate personal protective equipment, such as gloves and safety glasses, when working with electrical equipment. Never work on electrical equipment that is energized. Always de-energize the circuit and verify that it is safe to work on before starting any work. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. REDLEG panels are an essential component of many industrial and commercial electrical systems. By understanding their characteristics, applications, and safety requirements, you can ensure that they are used safely and effectively. Remember to always consult the NEC and other applicable standards to ensure compliance with all applicable regulations. Always prioritize safety when working with electricity. By following these guidelines, you can protect yourself and others from electrical shock hazards. In addition to the information provided above, it is also important to understand the different types of circuit breakers that are used in REDLEG panels. There are several different types of circuit breakers, each with its own unique characteristics and applications. Some common types of circuit breakers include thermal-magnetic circuit breakers, which use a thermal element to trip the breaker in response to an overload, and a magnetic element to trip the breaker in response to a short circuit. Instantaneous trip circuit breakers, which trip very quickly in response to a high current fault, and ground fault circuit interrupters, which protect against electrical shock hazards by detecting small imbalances in current flow. The type of circuit breaker that is used in a REDLEG panel depends on the specific application and the type of equipment that is being protected. It is important to select the appropriate type of circuit breaker to ensure that the equipment is properly protected. Another important aspect of REDLEG panels is the wiring. The wiring in a REDLEG panel must be sized appropriately for the load that it will be carrying. The NEC provides guidelines for conductor sizing. It is important to follow these guidelines to ensure that the wiring is not overloaded, which can lead to overheating and fires. The wiring in a REDLEG panel must also be properly insulated. The insulation must be rated for the voltage and temperature that it will be exposed to. It is important to use the correct type of insulation to prevent electrical shock hazards. REDLEG panels are typically installed in metal enclosures. The enclosure protects the internal components of the panel from damage and provides a barrier against electrical shock hazards. The enclosure must be properly grounded to provide a path for fault current to flow back to the source. This helps to protect against electrical shock hazards. In addition to the above, consider the importance of proper labeling of circuits within the panel. Clear, concise labeling helps in identifying circuits quickly during maintenance or troubleshooting. Consistent labeling across all REDLEG panels in the facility ensures ease of understanding for any electrician working on the system. Furthermore, ensure the panel has sufficient space for future expansion. Industrial facilities often grow or add new equipment, requiring additional circuits. Selecting a panel with spare capacity reduces the need for costly replacements or additions later on. Pay attention to environmental factors such as ambient temperature and humidity. Extreme conditions can affect the performance and lifespan of the panel components. Choose panels and components rated for the specific environmental conditions of the installation location. Lastly, remember to keep detailed records of all RedLeg panels in the facility, including their location, specifications, maintenance history, and any modifications made. This information is invaluable for managing the electrical system effectively and ensuring long-term reliability and safety.